All right. Good morning, guys. You are welcome to another edition of today's tutorial. Now, we are moving to the trig aspect of differentiation using first principle. Now, we have a question here. We're told that y equals to sine s using first principle. We are asked to differentiate. Now, if you have a question like this, don't forget in first principle, whenever you differentiate a variable, you have that variable plus change of that variable. Now, this is same thing as y plus change in y, then equals to sine. We have s plus change in x. Then what will you do next? You may change in y the subject of the formula. So we are changing y equals to sine s plus change in x minus y. And now this time around, our y is sitting as sine x. So it becomes change in y equals to sine bracket s plus change in x minus sine x. Now in first principle, whenever you have sine of this minus sine of this, you are going to apply this formula. Whenever you have sine c plus d, sine c, then minus sine d is the same thing as 1 over 2 cos c minus d, c plus d, then sine c minus d. All right. Now this time around, this thing has changed in y equals to our c is representing s plus change in x, while our d is representing what? S. That is, our c is s plus change in x, and our d is sitting as what? X. So this time around, substitute these values here into this what? Expression. So it becomes half, then cos. Oh, sorry. There's an error somewhere. It's 2. Then cos half, and sine, then half c minus d. Sorry for that little error. There becomes 2 cos half, then bracket. Our c is sitting as s plus change in x, then plus our d is sitting as what? X. Then we have sine 1 over 2. Our c is sitting as s plus change in x, then minus what? Our d is what? X. So this time around, we have change in what? Y equals to then 2 cos half bracket 2x plus change in x. S plus s is what? Is 2s. Then we are left with what? Change in what? S. Then we have sine. Then this is sitting as half. So s minus s we cancelled out. So we'll be left with change in what? X. So from there, this time around, it becomes, what you do, you can divide through by what? By changing what? S. Now, in dividing through by changing s, it becomes change in y over change in x, then equals to, so this one is sitting as 2 cos. So here it's sitting as brackets 2x over 2 plus change in s over 2, because this 2 is affecting everything inside the bracket. Then it becomes sine 1 times change in s, sitting as change in x, then over 2, all divided by change in what? S. So this time around, we have change in y over change in x equals to 2 cos bracket. This can cancel out this. We'll be left with what? X. Then plus change in s over 2. Then bracket. Here becomes sine change in s over 2 divided by this sitting at change in s over 1. Now, whenever you are changing these 2 times, the denominator move to numerator and numerator move to what? To the denominator. So we have change in y over change in s equals to 2 cos bracket s plus changing s over 2, then sine, then we have changing s over 2, then times 1 over changing what? X. So this is stating that changing y over changing s equals to 2 cos bracket s plus changing s over 2, then sine. This is stating as changing x over 2 changing x. Now I can easily split this. So this is stating as changing y over changing s equals to 2 cos bracket s plus changing s over 2. Then this is stating as 1 over 2, then sine changing s over changing s. And in first principle, whenever you have sine changing s over changing s, is equivalent to what? 1. That is sine changing s over changing s is equals to what? 1. That means anywhere you see sine changing s over changing s, can replace it with what? 1. So this is stating as changing y over changing s equals to 2 cos, then brackets, we have s plus changing s over 2, then half times what? Everything here is stating as what? 1. So what happened is this, is that this can cancel out this. So if you cancel out 1 times 1 is stating as 1, we'll be left to changing y over changing s, then equals to cos s plus changing s over what? 2. So what will you now do then? You can now limit changing s approaches 0. So that means anywhere you see changing s, you can substitute what? 0. We have changing y over changing s, then equals to cos brackets s plus 0 over 2. So from there, I can wipe from here. It becomes dy dx, then equals to cos. So what's left there is what? X plus 0 divided by 2 is stating as 0. So from there, dy dx is going to give us what? Cos x. So that is the final answer. So whenever you differentiate sine s, you will have what? Cos x. All right, let's move to the next one. All right, so we have y equals to cos x, okay, using first principle. Okay, so if we have a question, whenever I differentiate y, we have y plus changing y, then equals to cos, then we have s plus changing what? X. So this time our changing y is stating as cos s plus changing x, then minus y. Then our changing y is stating as cos s plus changing x, then minus y is stating as what? Cos x. So after that, whenever you have an expression like this, cos c minus cos d, it's stating as minus 2, then sine half c plus d, then sine half c minus d. Okay, in terms of the expression. So what you do, you can substitute these values into this place. So we have changing y, then equals to, for this, we have minus 2, then sine half. So our d, our c is stating as s plus changing x, while our d is stating as what? X. So what you do is substitute this word variable into this word expression. Okay, so from there our c is stating as s plus changing x, then plus, while our d is stating as x, then we have sine half bracket our c is written as s plus change in x, then minus x. So this time around we have change in y equals to minus 2, or this can cancel out this. Okay, no need of beating around the bush. So we are left with what? Minus sign. Then here we have brackets. 2x plus x give us what? 2x plus change in what? X. Then we have sign 1 over 2. This can cancel out this. We are left with what? Change in what? S. What you now do, you can divide through by what? Change in what? S. Dividing through by change here, because you are looking for dy dx. So it becomes change in y over change in s equals to minus sign bracket 2s plus change in x, then sign 1 over 2 change in s, then all over change in x. So from there it becomes change in y, change in s, then equals to minus sign, then bracket 2x plus change in s, then sign change in s over 2 times 1 over change in x, or divided by, let me not jump, change in s over 1. Change in s divided by this, divide is sitting as this, change in s is dividing 1, still have change in what? X. So from there we have change in y, change in x, then equals to minus sign bracket 2s plus change in x. So this is sitting as sign change in s over 2 times 1 over change in x. So this is as change in y over change in s equals to minus sign bracket 2s plus change in x. Then this is sitting at 1 over 2 sign. We are left with change in s over change in what? X. 1 over 2, which is this, change in s, change in s. I told you, whenever you have change in s over change in s, sign change in s over change in s is equivalent to what? 1. So what you do, you can replace everything here with what? With 1. So it becomes change in y, change in s equals to minus sign bracket 2x plus change in s, then 1 over 2, then times what? Times 1. So this is the same thing as change in y over change in s equals to minus sign. Don't forget this 2 here is sitting as 2x plus change in x, then half. So everything here is affected by this half. So it becomes change in y over change in s, then equals to minus sign, then bracket half times this is sitting as 2s over 2, then plus change in s over 2. So from there this can cancel out this. Let's take it up. If that cancelled out, it becomes change in y over change in s, then equals to, we are left with minus sign x, then plus change in s over 2. After we divide, we are still having what? Change in s. The next step, you limit change in s to be what? 0. That limits change in s approaches 0. We have change in y, change in x equals to minus sign bracket s plus 0 over 2. Okay, so it becomes dy dx equals to minus sign, then bracket x plus 0. So we give us minus sign, s plus 0 still give us what? X. So that is your final answer. So whenever you differentiate cos x, you have minus sin s. But if you differentiate sin s, you have what? Cos x. So let's take more questions on that.